All right, let's start out our lesson today by talking about what a mathematical expression is and what a mathematical expression is not. So let me give you, I have 3 examples that are good examples, and then I have one that's a bad example of an expression. So first example, we have, I'm going to hold this closer to the camera, we have a plus 3. This is a mathematical expression because it uses symbols, it uses numbers, and it uses a mathematical operation, in this case, addition. A plus 3 is a mathematical expression. Similarly, 4x is a mathematical expression. It uses numbers, it uses symbols, and it has a mathematical operation going on, in this case, multiplication. 4x would mean 4 times x. Here's a little bit of a different one. This is a mathematical expression. This is specifically a numeric expression. If you notice, there are no symbols in this expression. They're all of the digits here, they're numeric. So we have 3, we have 2 in parentheses squared plus 1. So it's 3 times the quantity 2 squared plus 1. That is a mathematical expression, even though there are no symbols. It's still an expression. And we also have several different mathematical operations going on. Multiplication, we have an exponent, we have addition, and well, we even have some parentheses thrown in there as well. Not that that's an operation in this case. Okay, those are my 3 good examples of expressions. Let me show you a bad example. At first glance, this looks similar. We have 2x plus 4 equals 7. The problem here is the equal sign. An expression does not have an equal sign. That's an equation. We're going to save that for another day. Expressions don't have equal signs. Equal signs, it usually indicates that we're going to solve for a variable. If you recall from Algebra 1, I'm sure you did that many, many times. So 2x plus 4 equals 7 is not an expression because it has an equal sign. So this is a big no. This is not an expression. An expression will have symbols, it will have numbers, it will have mathematical operations, but it will not have an equal sign. Okay, why are we talking about expressions? Well, there's a couple answers to that question. One is mathematical expressions are kind of the foundation for the rest of what we do in algebra as far as solving equations, graphing equations, comparing equations, or functions, all these sorts of very algebra typical words begin with mathematical expressions. So we want to make sure that we know the rules of how to simplify them, how to evaluate them, which means getting a numeric answer out of them. So you may recall the concept of, I don't have anything to show you here. Let me actually write this out. I'm going to write it here for you to look at. Bring back some memories maybe from past classes. So we have, I'm going to write PEMDAS. And this is an acronym that's used in many, many, many math classrooms to tell us what order to evaluate expressions in. What it means is that we always evaluate parentheses first, then exponents, like when I square something, then multiplication, division, addition, subtraction. So that's what this means. That may or may not sound familiar to you. I'm guessing it probably does for most of you. However, we're going to talk about this a little bit differently today. I want to talk about how the foundation for how we evaluate expressions and how we simplify them is based on how strong or how powerful the math operation that we're looking at is. So that's going to sound like a big mouthful, but let me show you what I mean. So we're going to start with addition. We're going to talk about how powerful is addition. So right now I have the number 2, and I'm going to talk about adding numbers onto 2. So let's start by 2 plus 2, which equals 4. Pretty basic arithmetic there. I'm going to move up. So 2 plus 2 gives me 4. And 2 plus 3 gives me 5. Okay, so if I add more, I get more, right? We know that that's true. 2 plus 2 is 4. 2 plus 3 is 5. 2 plus 4 is 6. And then if I jump ahead, because you might notice I'm making a pattern here. Add 2, add 3, add 4. What if I add 10? Well, 2 plus 10 will give me 12. Not the most powerful math operation out there, but it gets the job done. The more I add, the bigger my number gets. So I went from 2, I added 2, 3, 4. By the time I added 10, I got to the number 12. So keep that in mind. Let's talk about the operation of multiplication. I'm going to start with 2 again. What happens if I take 2 and multiply it by 2? So we just said add 2, add 3, add 4, add 10. What happens if I make the same pattern of operations but using multiplication? Well, 2 times 2 gives me 4. 2 times 3 gives me 6. So I'm already hopping ahead. Before, I had to add a lot more before I got up to 6. 2 times 4 gives me 8. And if I hop ahead to 2 times 10, I get 120. So if I just add 10, I get to 12. If I multiply by 10, I get to 120. So I think we could agree, and you already, I'm sure, know this, but I want you to be thinking clearly about what I mean when I say that multiplication is much more powerful than addition, or it's stronger. When I use multiplication, I have a stronger push to make numbers bigger. This is more powerful than addition. Multiplication, more powerful than addition. Now let's talk about exponents. What happens if I take the number 2 and I use exponents to make it bigger? So I say first, 2 squared gives me 4. Just like 2 plus 2 gave me 4. 2 times 2 gave me 4. 2 squared gives me 4. It's kind of, well, it's not really a coincidence. It's only special for 2. Now let's say I cube it. 2 cubed, 2 times 2 times 2, gives me 8. So 2 squared is 4, 2 cubed is 8. 2 to the 4th power is 16. And if I jump ahead to 2 to the 10th power, I get 1,024. So let's compare. If I add 10 to 2, I get 12. If I multiply by 10, I get 120. If I use the power of 10, I get 1,024. So I think we would agree exponents are the most powerful of these 3 options. We have the rather weak addition. It still makes our numbers bigger, but much more slowly. Multiplication is more powerful, and then exponents are the most powerful. And those correlate, so addition and subtraction go together. Let's say if I have, do I have the right one here? Yes. If I have subtraction, let's say I start with 100 and I subtract 2, I get 98. If I take 100, subtract 3, I get 97. If I take 100 and subtract 4, I get 96. And if I take 100 and subtract 10, I get 90. So I'm making it smaller very slowly, just at the same speed that I can make numbers bigger using addition, right? These are equal powers. This makes them bigger, this makes them smaller, but at the same speed. Addition and subtraction work at the same speed or with the same strength. I have a purpose. We're going to get to somewhere in a minute. Got to keep making these correlations, though. Same thing with division, multiplication and division. I can start with 100 divided by 2, which gets me all the way down to 50. That's a pretty big leap. 100 divided by 3 gives me 33 1/3. 100 divided by 4 gives me 25. And 100 divided by 10 gives me 10. So if we compare, where's my subtraction one here? Subtracting by 10 gets my 100 down to 90. Dividing by 10 gets my 100 all the way down to 10. So I'm making numbers small much more quickly with division than with subtraction. So who's more powerful? Division is more powerful. In fact, division is as powerful as multiplication. Multiplication makes it bigger, division makes it smaller. At the same rate, they're both equally powerful. One just makes it bigger, one makes it smaller. Last but not least, we can compare this to roots. So if I take just like powers, right, exponents, I can take the square root of 100 and get 10. I can take the cube root of 100 and get 4.64 approximately. I can take the fourth root of 100 and get about 3.16. And I can take the 10th root of 100 and get about 1.58. So let's compare. If I subtract 10 from 100, I get 90. If I divide by 10, 100 divided by 10 gets me all the way down to 10, and the 10th root gets me all the way down to 1.58 approximately. So what's the most powerful operation when it comes to making things small? Roots. Roots are the most powerful. In fact, roots are as powerful as exponents, but exponents make things get bigger and roots make things get smaller. Okay, if you feel like this is something that this is something you already know, I don't doubt it. I'm sure you did kind of know that already. But we don't tend to talk about the strength of mathematical operations in that way very explicitly. We might kind of just imagine, like it's kind of in the back of our head, but I want to bring that right to the forefront of your thinking as we're talking about simplifying expressions. If you think about the operation of PEMDAS, which let's go back over here. PEMDAS, the traditional operation, tells us that when we simplify expressions, we use this order of operations. We start with parentheses, go to exponents, move down to multiplication and division, and then to addition and subtraction. If you notice, what they're really saying here is that, let's ignore, I'm going to draw a line here. A very crooked line. That's all right. Ignore the first letter, P, for a second. But PEMDAS, what we're really talking about here is how powerful are our operations. Exponents are the most powerful. Multiplication and division are on the next level. And then addition and subtraction are the weakest. When you simplify expressions, you start with the most powerful and you move down. The only exception to this, of course, is the parentheses. So let me show you this other hierarchy that we have. So here's what I'm going to show you. Let's talk, instead of just saying PEMDAS, let's talk about what we really mean. Sometimes we can make acronyms in math and never explain why they work. It sounds like somebody just made it up just for the fun of it. This came from, you're still welcome to use PEMDAS if that helps you remember, but I want you to know where it came from. It comes from the fact that exponents and roots are the most powerful in the hierarchy of math operations. So we always evaluate them first. Then we use multiplication and division because they're kind of the middle of the road, powerful math operations. So we do them second. Notice that they're on the same level. One of the misnomers about PEMDAS is that you're supposed to do all the multiplication before you do the division. And that's not true. You actually want to do multiplication and division at the same time. And the way you do that is you always evaluate from left to right. I want to do it your left to your right. So from left to right. Multiplication and division, you evaluate them at the same time, but you move from left to right in the equation when you do it. Last but not least, we have addition and subtraction. That is the weakest. They still are valuable mathematical operations, but they're the weakest. They make things get bigger or get smaller at the slowest rate. So we evaluate them last, and we do them at the same time. Again, PEMDAS makes it look like you should add before you subtract. That's not true. You should add and subtract at the same time, and the way you do that is by moving left to right in a expression. If you're having a hard time visualizing what I mean when I say simplify, I'm going to give you an example in just a second. But before I say that, there is one caveat. Now, I like the word caveat because it means it's kind of like the exception to the rule. I'm giving you a warning. Yes, this is all true, but of course there's an exception to the rule, and that is parentheses. So here's my big caveat. Parentheses supersede all the other operations in the hierarchy. It's our way in mathematics of drawing attention to something that's more important than even the most powerful math operation. So if you see parentheses, your eyes should go to them first. You always look at what's inside. So I'm not talking about what's going on in the outside of the parentheses. What's going on in the inside of the parentheses. Evaluate that first, and then we move through our hierarchy. Okay, that's my first overview. This is going to make even more sense after we look at an example in the next video for this lesson. If you're not sure now, what I recommend you do is go look at the next video, watch the example, and then come back and watch this video again, or at least this last part, and see if by going back to back you can put together the example and the hierarchy. All right? Hope that goes well.